Welcome back to Math 95, Section 3.2, Introduction to Functions. This word function is going to be a very, very important word in your math world. So this is a vocabulary lesson more than anything else, but it is the foundation for a lot of what we're going to do. Our objectives are mainly to get familiar with definitions. We need to understand what a relation is. We want to understand domain and range. We want to get a good solid foundation on the word function. And then with that word function, we want to learn how to use the vertical line test, find the domain and range of a function, and then use what we call function notation. Quite a large order, so let's jump right on in. We need to get some definitions under our belt before we can get into math. In order for you to understand what I'm saying, you need to be familiar with the words. So just starting with some foundational words, I'm translating the vocabulary that your book has written in those little, I think they're yellow, maybe purple boxes. The first word we're going to deal with is relation. A set of ordered pairs. Set means a collection. So this is a collection. Now, ordered pairs, remember, those were our x's and y's. So a relation is a collection of connected values. In other words, it's a bunch of x's with y's that correspond to them that are connected in some way. In this collection, we can think of it almost like a machine. If we have a machine, so this is like a machine, like a vending machine almost. That's supposed to be an E. It's like a vending machine in the way that if I plug something in, I get something out. So the domain definition is the set of the first components of a relation. The first components of an ordered pair are our x values. So these are going to be x values. But that's not a very specific definition. It's the set of the x values of a specific relation. Not all relations will be able to have all x values. So the thought is an x value, but I have a 5 or 6 word definition that might help you hold on to this a little bit. The domain is all possible valid input values. If you think of a relation like a vending machine, the x values are your inputs. So I plug an x value in, and all of the possible x values I can plug into a relation make up what we call the domain. Think of the domain as where the relation lives. Like your own domain would be your house. Another interesting piece of this is that domain has the word in it, and it goes with the input. It's one of the little tricks that I like to help me remember that domain goes with the input. Now, your book also says that the range is the set of the second components of a relation. And the second components in our relation correspond to the y values. Now, again, y values is too general of a definition. So if you think about it, I plug x values into my relation. So I get out y values. So the range is all possible valid output values. these are going to correspond with the inputs. So the range is the spread of the values that the machine will put out depending on what inputs you put in. The last word we want to define on this page is a function. A function is a type of relation. It is a relation, but it's a relation in which, now bear with me here, each first component of the ordered pairs, these are x values, each x value, so this is each x value, corresponds to exactly one second component. Those are the y values. So each x value has exactly one y value. I can summarize this just a little bit more. What I like to say is each input, because not all of our inputs will be x's. That's what we like to use, but I might use q's or t's or cotton candy or something else. So a function says that each input has exactly one output. So for any x value that I plug into my relationship, my function, I will only ever get out one y value. It is very predictable. If I plug something in, I know exactly what I will get out. And that's what makes it a function. Blank page. Get rid of that one. So before we get any further, I just want to practice this idea of domain and range. There is some notation that we need to get used to in writing our domain and range. There are two types of notation we'll be using. We'll deal with the first type right now. In this page, we're going to be dealing with something called set notation. So if I want to determine the domain and range of this first relation, remember that the domain is all possible valid input for x values. So as I look at this graph, I need to find my x values. So here's my x-axis. My x values will be the horizontal grid values. So if I look at the dots that I have, they all wind up on the same x value, the x value of -3. So my domain is -3, and it's only ever -3. So I'm going to put that in these little curly braces or kissy brackets. That's the set notation. The set notation is the braces. Now, the range for this function, I have several different values actually. I have 5 different values. So my range, I like to list these in size order, so most negative to most positive, or from left to right, bottom to top. My range is going to start with this value down here, and that's -1, 2, 3, 4, 5, -5, -1 is the next one right here. Then I see a +2, a +3, and a +5. What this set notation says is I don't know anything between 5 and -1, and I don't know anything between -1 and 2, between 2 and 3, or between 3 and 5. I only have information about my relation at these specific places. That's why we use this notation. So next I want to answer the question, is this a function? And if I remember the definition of a function says that each input has only one output. But for this relation, my one input, I only have one input. That input is 3. That 3 maps to 5 different outputs. This is 5 outputs for one input. It cannot be a function. Not a function. It breaks that rule. For part B, as I look at this, I want to look at my input values. For my domain, again, I want to start with the smallest input value, and I've got a 1, a 2, a 0, and a 0, so I start with a 0. I have a second 0, I don't need to write it again. And then I'm going to write my 1, and then my 2. Again, I use the squiggle brackets because I don't have any information about what's happening between 0 and 1 and 1 and 2. Then I will look at my range, and I see that my range, the smallest output value I get is this -2. The next smallest would be this 3. Then I have a 6, and then an 8. So we've listed our domain and range. Now we need to answer the question, is it a function? Again, to answer this, I'm going to look at my inputs. I have 3 inputs and 4 outputs. Immediately, if I have more outputs than I have inputs, we can know that it is not a function. Specifically, because these 2 pieces of my relation have the same input and different outputs. So one input has 2 different outputs, but a function says each input has only one output. So this one is not a function. For part C, you'll see these diagrams in your book, and the input is the first set, and the output is the second set. Just so we're clear on what that means. Let me just kind of break this up a little bit. So for my input, I have a 3, a 6, and an 8. My input, my domain, is going to have a 3, a 6, and an 8. My range for this set, it's only going to be the values that have an input mapped to them. This 7 won't actually be part of our output, part of our range, because it doesn't have a corresponding input. So my range is going to be 2, and 9, and 12. So if I just look at my domain and my range, if I ignore my table and just look at my domain and my range, I have 3 inputs and 3 outputs. So this looks like it very well might be a function. But if I look back at my graphic, I see that the input of 8 corresponds to both 12 and 2. So this input has 2 outputs. So this, again, is not a function. Well, we didn't start off very promising, did we? Everything is not a function. Don't worry, we will get to some where we do have functions. Let's see what we have on the next slide. Vertical line test. So before we do this, I am going to actually let you take a break. The vertical line test is another way to test to see if something is a function. So I'm going to let you practice what we've done so far, and I will record this next bit in another video. All right, I will see you soon.